Hello, everyone. All right, so this is a session on Lakehouse Monitoring, which is our data quality solution built on top of Unity Catalog. So hi, everyone. I'm Kasey Uhlenhuth. I'm a product manager on the Databricks team, and I'm joined by my esteemed colleague. Do you want to introduce yourself?
Hi, everyone. My name's Jacqueline, a product manager working on Lakehouse Monitoring.
Awesome. So let's go ahead, and I'm going to quickly go through some quick slides, and then we all know that we're really here for a demo to show us what Lakehouse Monitoring is. So Jacqueline's going to take us through a beautiful end-to-end demo of how you can use Lakehouse Monitoring to monitor data quality in your Unity catalog. All right, so today we're going to quickly go over what the heck is data quality, why should you care about it. Then we're going to go over what is Lakehouse Monitoring and how is it kind of unique in the data quality space. Then we're going to give you what we've all been waiting for as a demo of Lakehouse Monitoring, and we're also going to go through what's coming next with Lakehouse Monitoring. We have really exciting things coming in the next couple of months, and so we want to give you kind of a sneak peek of what we're working on so it can help kind of make decisions on whether to build or buy in the data quality solution space. All right, so what is data quality? Well, we hear lots of things from different customers like, hey, is this data what I thought it was? Did all of my data arrive that I expected to arrive? Did it arrive on time like it's supposed to? Is it full of nulls or is it full of zeros and nans? Is it actually valid? Is it unique when I actually expect it? Are my primary keys unique? Is this ID column unique or not? And then there's this whole question of is it monitoring? Is it observability? So there's many different things that sort of encapsulate what data quality is. And at Databricks, we believe all of these things are part of data quality and that we need to be able to measure and monitor all of these different things. So why do you need to monitor data quality? Well, this might be a familiar situation where all of your data pipelines are running perfectly, green everywhere, executing, you've done your job, check on your SLA, but then it turns out something's gone horribly wrong with the data inside of that pipeline. So everything executed well, but the quality of what was inside, not so good. And what ends up happening is you have one of your data analysts or business stakeholders ends up slacking you, being like, what the heck is going on? That my graphs don't look like they're supposed to anymore, and I have to go debug and figure out what went wrong. Or, because we're the data and AI company, you may have a model in production, and it's correctly creating inferences, but the inferences it's creating, not what you expected. And it turns out the data world around your model has completely shifted, and now you're going to need to retrain your model in order to keep it up to date. So these are the reasons, or these are sort of the scenarios that we hear a lot from our customers of, hey, things are executing correctly, but the things that it's producing inside are not the quality that we're intending them to be. And so what ends up happening is you create SLAs on the delivery of the data or the delivery of the inferences. But what you really want to have is SLAs on the quality of what you're delivering. That's really hard if you don't know how to measure quality. So data quality is important because it builds trust in your data. Many people, for example, in the machine learning space, end up turning off their models because they end up deteriorating so much in production that you might as well not even have a model at all. And so you need to be able to build trust in these different things. Also, people build very important business dashboards on top of data. They do financial forecasts on top of that data. If the data is not trustworthy, pretty hard to make data-driven decisions off of that data. Another thing that data quality allows you to do is it creates autonomy. So right now what we see is a lot of our customers are in a way bottlenecked through their data engineering team, where they're not really trusted to build the data ingest pipeline that puts the data into the Unity catalog. So this whole bottlenecked operation where you can't actually own your data. So another team owns getting the data into the Unity catalog, which is different than the team that actually needs to consume and build on that data. And because of that, you have this bottlenecking going on, and you do it because you don't want people to put PII in there. You don't know what people are going to do. You can't put the safeguards you need in place. And so that's why these sort of processes came about that end up making it so you can't have a self-serve data platform. And the last thing is you really need to just drive business success. So you want everyone to be able to access this data securely. You want the data to be high quality, and it's really hard to do that if you don't have high quality data that you can trust. All right, so if data quality is so important, why doesn't everyone have a data quality solution? And in fact, a lot of our customers do not have data quality solutions today. Can we get a show of hands in this room who does not have a data quality solution today? Yeah, that's what I thought. It's like 40%. So many customers don't have one today, and they all know they should, but they don't because of these reasons. So the first, many data quality solutions are high friction. So they might like measure all this stuff for you, but then you have to build the dashboard. What a pain. No one wants to at the end. So data quality becomes like this afterthought where it's like, oh, I have to quality monitoring on this. I have to build all these dashboards, and then I only have to look at them when things go wrong. So why did I pull this effort into this dashboard that I look at maybe twice a year? And so they're high friction. The next is, okay, once you overcome the friction for one table, you build this dashboard so you understand quality. Now you have to do it for 1,000 tables. Forget it. You're not going to do it. So it's very hard to scale a lot of these solutions. And then the second thing is you have to write data quality rules, validation rules on top of these so that you can get like PagerDuty alerts if things go wrong. But if you have like, a table with thousands of columns and you set up a rule for every column, that's a lot of alerts you could get one day. And then put on 1,000 tables, like you're going to turn off all your alerts. And then what was the benefit of data quality at all? And so these are a lot of the challenges that we're seeing in the data quality solutions today that we're trying to tackle with Lakehouse Monitoring. And with that, Jacqueline's going to walk us through what Lakehouse Monitoring is and then demo it.
Yeah, thanks, Kasey. So we know that teams, like yourselves, want to monitor many different assets. So this can range from, bronze, silver, or gold tables, time series, materialized views or streaming tables, feature tables, or if you're monitoring a model, this can come into like inputs and outputs in an inference table. With all of these tables, they may be coming from multiple different frameworks, whether that's dbt, DLT, workflows, serving, or some third-party serving. All of these tables can be created with different frameworks, or they could be hosted differently. But with Lakehouse Monitoring, it's really this single unified solution where you can attach a monitor to any of these tables in the same way. What this allows you to do is you have a scalable solution across your data and AI. What we'll do from there is Lakehouse Monitoring will generate 2 metrics tables, a profiling table as well as a drift table. In your profiling table, you can find metrics such as count, percent null, min, max, median. And in your drift table, you can find metrics like delta in percent null, delta count, things like that. So essentially, you just get automated profiling out of the box. You don't have to maintain a profiling pipeline. You don't need to write these queries yourself. What we'll do from there is we'll visualize all of those metrics in an out-of-the-box dashboard, which you'll be able to see very soon. And then what you'll see there is you'll have visualizations of what your metrics look like over time, and you don't have to create that yourself. The next step is you can also set expectations and alerts on those metrics. So what this means is you can catch if there's been a certain threshold that was exceeded on the metrics, or you can track how the metrics change over time. So essentially, Lakehouse Monitoring is a solution for both data and AI. You get automated profiling of any delta table in Unity Catalog, as well as model drift and performance metrics if you're monitoring a model. So Lakehouse Monitoring ensures that you get quality across your entire data and AI estate. On top of that, since we're built into Unity Catalog, you get to leverage things like the metadata, as well as governance tooling. And since it's a fully serverless product, you don't have to worry about tuning compute infrastructure or anything like that, and we'll handle all of it for you. So this is why we're super excited to be announcing that it's generally available today. That's the best part. You probably heard Matej announce this earlier today, but it's GA. So that means you can go to any table in UC today and it'll be ready to use. And it's super easy to get started with your quality journey today. All right, so now for the part we've all been waiting for, the demo. Okay, so before we dive into the demo here, let me set up the scene and pretend like we're in a certain scenario together. So let's explore this scenario where we're a retail company tracking transactional data. There might be multiple reasons why we're doing this. For example, fraud prevention, or we might be analyzing sales trends to see which products to promote, or we might just be doing reporting on things like what's the most popular payment method. All of these questions are essentially things that we need data to make decisions on. So we rely on data-driven insights in order to answer business questions so that we can impact things like resource allocation or strategic planning and business success with confidence. All right, so now that I've set the scene here, let's put our data engineering caps on and pretend we're working for this retail company. And we're just at our desk one day, but then we see a ping, Slack message. You get something from a data analyst saying, hey, I'm using the transactions table that you're maintaining to complete a report for leadership, and I'm getting some nulls. Can you help me take a look ASAP? All right, so at this moment, you might be thinking multiple different things. You probably have several questions in your head, like what's going on? Where do I start to investigate? More particularly, you might be asking questions like, what columns are affected that they're looking at? Is this an anomaly? How long has this been a problem? Which tables are impacted by these nulls? And what was the root cause? So after receiving a Slack message like that, you probably have numerous questions circling in your head. This is where Lakehouse Monitoring comes in. Let me show you how monitoring can help you answer these questions before downstream processes get impacted. So with that, let's hop into Databricks. And here we get to the Lakehouse Monitoring dashboard, which is generated out of the box for you. So we know that it was a problem with nulls. Let's go to the percent null section of the dashboard. Right away, we see that there are 5 columns in the last time window that had high percent nulls. This means that the last time our metrics were recalculated, there were 5 columns that we determined to have high percent null. On the graph on the right, we see these columns plotted over time. And in particular, we see preferred payment method looked like there was a spike around April 30th, exactly on May 1st. So let's filter this chart down. So historically, it looked like there was maybe around 5 to 10%. And then all of a sudden, on May 1st, it spikes all the way to 42%. This definitely looks like there's a problem with the nulls in this column. So right away with Lakehouse Monitoring, we were able to figure out which column was an anomaly right in front of us with this visualization. You didn't have to write a query for this. You didn't have to maintain a profiling pipeline. It was visualized out of the box for you. All right, so at this point, I'm looking at preferred payment method. I'm kind of curious to see how the values for this column have drifted over time. Since this seems like this is related to string column, I'm gonna head over to the categorical distribution change section. So here we have a heat map showing all of the categorical anomalies over time, and there seems to be 4 columns with high categorical distributional change. And what are those 4 columns? Great, they're identified right here. And just as I suspected, preferred payment method is one of them. So let's filter down this chart and see what's going on. Filter by preferred payment method, and bam. Okay, so there's bank transfer, credit card, debit card, PayPal, and then nulls were introduced on May 1st. So this is what I was expecting, but I can see exactly the breakdown of the values in this column. And null definitely seems like it spiked in the last time window. As you may have noticed from this chart, we can also see the other columns that have had high categorical change in the last window as well. And payment method looks like to be one of them. So I don't know if it's just me, but these 2 columns seem related. Let's see what payment method looks like. I'm gonna filter by payment method, and there it is. So it looks like Apple Pay was introduced in the last time window on May 1st. This to me signals that we forgot to update preferred payment method when a new payment method was introduced. So directly from the dashboard, I was able to find that this is kind of the cause, or it gives me a clue of where to start my debugging journey. There's probably some upstream transformation logic that I need to update to account for new payment methods, for example, if Apple Pay or Google Pay was introduced. From there, I'm probably curious right now to see what are the impacted tables that have also received null. So since Lakehouse Monitoring is built directly on Unity Catalog, let's head over to the Catalog Explorer and see if we can figure out what's going on there. So I'm gonna go to the silver table here and then click on the lineage tab. And I can actually go see the lineage graph. Oops. See the lineage graph for this table, transaction silver. So it looks like on the left, I can see all of the upstream tables that affect this transaction layer, as well as the downstream tables. I can expand all the columns and filter on preferred payment method. And it'll show me all of the relationships between the tables. So right away, I see that user bronze is where I reference preferred payment method. So there's some transformation logic between user bronze and our transaction layer that I need to update in order to prevent nulls from appearing in that column at any time a new payment method is introduced. On the right side here, I see all of the downstream tables that also take on preferred payment method. In particular, I see that there's this table called payment method usage that references it, as well as the table owner who I can contact to let them know that they probably also got impacted by the null problem. So what we saw here is we were able to answer all of the questions as to what the root cause for this data anomaly was, as well as who was impacted, all in the data platform. We didn't have to leave and go to some third-party tool. We could see it all in one place, all as a unified solution. All right, so at this point, this is everything that's available today in GA, so you can go into Unity Catalog, go to any quality tab, and then get this out-of-the-box dashboard, as well as explore the data lineage associated with the tables. So this is all readily available to use. In the next half of the demo, I'm really excited to show you where we're going next with the product and how we can go from something like this, a reactive process where we're answering to a message from a downstream consumer, to a proactive alert from Lakehouse Monitoring saying, hey, we actually detected this problem for you ahead of time before the downstream consumers are impacted. So that's what the next set of features will help you address. I'm gonna go head back into monitoring right now. And if we go back to Catalog Explorer, oops, not this one, and we go to the schema level view that we saw earlier, you may have noticed that there's a bunch of health indicators next to these tables. So all of these tables are now populated with green and red indicators telling you if a table has met quality expectations or not. So green if it met all the quality expectations on the table, and red if it failed at least one of them. So this is one single view that anyone in your organization can come to understand if a table is healthy or not. So you can imagine for downstream consumers, like a data analyst, they may be coming to this table to see, hey, can I use this table right now? It looks like sales gold is okay to use, all of these are okay, but transaction silver has a problem. If you're a data producer, the data engineering team, I can come to this view and see, hey, transaction silver requires my attention right now. There's a quality expectation that failed, let's go and fix it. So let's go ahead in and see what these expectations are. So by clicking that button, it takes us to the quality tab and it'll list all of the expectations and their associated status. So we'll see on the right here, all of the expectations. There's a primary key constraint, a foreign key constraint, as well as a % null on preferred payment type. So the first two are passing, which tells me that transaction silver has no duplicates because the primary key is validated. And the foreign key properly references another table's key user ID. The one that I should be concerned about is % null, as we saw earlier. So Lakehouse Monitoring was able to catch that there was actually a problem in this column before I had to go in myself to dig into it. All right, so the exact expectation that we wrote here is that percent null on preferred payment type is less than 10%, and that was the configured threshold. I can now go click into this query. That'll take us to this separate tab, and it'll show you all of the violating records. So in just one click, I was able to identify all of the transaction IDs that had a null preferred payment method. And now I can take all of these IDs and fix them before my downstream consumers are impacted. And this is where we're heading next with expectations. So if we head back to this view, these are essentially rules that we configure on the table. You may be asking at this point, how do I know what type of threshold to set, or what threshold exactly? 10%, 20%? Usually we hear from customers that this is just like a gut feeling, or if they understand the data, that's how they arbitrarily set a threshold. But as we all may know, this can often lead to noisy alerts where your team is bombarded by all of these notifications based on some arbitrary threshold that we set ahead of time. Let me show you this upcoming feature that we're putting out to help you reduce noise. So if we go into the dashboard that we saw earlier, now we notice some new fun colors. So on the right here, I'm going to zoom in. Oops. Zooming in, you see that there's like 3 lines on the right here. These lines are forecasted metrics that Lakehouse Monitoring intelligently predicts based on the profile of your data. So here you can see for data volume that the threshold reflects spikes that were synced with the hours where there's usually higher transaction volume. This will account for things like seasonality. So for example, if you got higher volume for certain hours of the day, or for certain months to account for things like the holidays. And if we go to the percent null section now, we also see the same line as before for preferred payment method. And we can tell that right away on May 1st, when it spiked all the way to 40%, it was indeed way over the upper threshold. So with this, we also can zoom into what exactly the metrics that we predicted. The upper threshold was around 15%, is something else that I noticed, so the green line there. As you may have recalled, the rule that we set earlier with the expectation was a threshold of 10%. So what this tells us is we can actually tune that threshold to 15%, and my team should see less noisy alerts. And this is kind of what we're putting out next. Where eventually we want to take this. Not only do we want to put out the forecasted metrics, but we want to automate this process for you. So we want to build towards this world of automated expectations where we intelligently predict the expectations on your data based on the previous profile of your data. And if you like what you've been seeing so far in the demo and all of these features, to help you get started on this quality journey with us and show you how you can get to this stage, I'm going to walk through exactly how to set up a monitor so that all of you guys can walk away from the session and know exactly how to get started. Let me go hop into a table without monitoring set up. So I just chose a table in my schema. Yes. So this is so that was kind of the demo of like all the features that were coming up. And now I'm going to walk into like how you can actually create a monitor so that all of you can walk away with an idea of how to get started. We'll also go through some best practices so that you know how you can like create monitoring to really scale out to your entire catalog. Okay, so when I land into any table in UC, it takes us to like this overview tab. But where you'll want to go is this quality tab. So on the very far right. And I'll just take you to this page where it says create a monitor for this transaction silver layer. I'm going to click get started, and then you're met with this dialog. So you'll see there's profiling, and then there's 3 different profile types: time series, snapshot, and inference. So for a time series, essentially what this will do is aggregate the quality metrics over time windows. So you would get all the metrics. It could be aggregated by day, hour, week, etc. For a snapshot profile, the quality metrics are calculated over the full table. So every time the metrics are refreshed, they're recalculated over the entire table. For an inference profile, in addition to the quality metrics that you get from time series, you'll get model performance and drift metrics like accuracy, precision, F1, recall. And you can compare these metrics to optional ground truth labels or a baseline. So in general, for tables, if you have a timestamp, we recommend getting started with a time series profile and enabling something called change data feed. Similarly, if you have a model that you want to monitor, we also recommend you go with inference with change data feed. So I'm going to tell you exactly what that does. I'm going to click into time series real quick, and you'll see like this warning from us that says, hey, change data feed is not enabled for this table. So essentially, if you turn on CDF, what we'll do is we'll only process the newly appended data, and you get incremental processing. What this means is that you get more efficient execution, as well as if you scale this across your entire catalog, it helps you save on costs. So similarly, for an inference table, we would also recommend doing change data feed. I'm going to quickly cover snapshot as well. So snapshot is the one profile where we don't support change data feed because we'll need to process the entire table every refresh in order to calculate metrics for the entire table and help you monitor characteristics over time. So in general, if you want to scale monitoring to your entire catalog or across many different tables, we recommend going with a time series for a table with a timestamp column, or inference if you're monitoring a model. So I'm going to go in and show you what a time series looks like. We're met with metric granularities as well as a timestamp column. So for metric granularities, this is kind of what we were talking about earlier. You get to aggregate metrics over different time windows. You can see all of these choices. So you can do multiple. For example, I want to see my metrics aggregated by a day or aggregated by an hour, as well as I can easily search for what my timestamp column is, so transaction date. So just with a few clicks here, we configured the monitor. And in advanced options, what I can see here is that on default, we'll set a daily schedule for your monitor. So this means that it'll refresh on a daily cadence. And that's how often that your quality metrics are recomputed. So this is different from metric granularities because metric granularities is essentially how we aggregate or group by your metrics. And then if there's a failure in the refresh or the monitor fails to create, we'll also send you a notification. So just with a few clicks here, we can create the monitor. And this may take a while depending on the size of your table, but we'll let you know if there was a problem with setting it up and send you an email notification. After the monitor completes, you'll get the profile metric table as well as the drift metric table, and we link this for you. So as we covered earlier, these are just metrics tables in your account. And what you can do is you can join them with anything else in your account, or you can query them directly. After the monitor gets set up, we can go view the dashboard. So let's go click into the dashboard here. And we already kind of got a sneak peek at this earlier, but we can really dive deep into all of the sections. So what we calculate here is a data volume section that helps you identify changes in data volume by tracking row count of the table. So you'll see what the row count was in the last time window, as well as what it looked like over time. So you can tell if it's historically normal. We follow the similar design pattern for the rest of the dashboard. So for data integrity, we can see percent nulls, as we saw earlier with the problematic preferred payment method. We'll show you there's 5 columns with high percent null, as well as what they look like over time, so you can identify spikes or drops. Percent zeros is similar. We'll show you what problematic columns look like over time as well. And we'll also identify for you what those problematic columns are, all in one place. So just with this table here, we'll show you the 5 columns with high null that we found, as well as the columns with high percent zeros that we found, without you having to write this query yourself. It's right there. The next section is numerical distribution change. So here you can detect any numerical anomalies in your data if there's been significant shift in your numerical columns. So we'll show you there are like 3 columns with high numerical distribution change. We'll identify what those 3 columns are, and then we'll plot the range over time. How we determine if there's numerical distribution change is essentially we compute these numerical drift tests, which you can see on the left here. We compute KS tests, PSI, WD, and you can really configure this query to use any of them. On default, we'll determine if a column has high numerical change based on if the p-value is less than 5%, so if it's statistically significant. But you can also configure that because we supply all of the underlying queries to the dashboard. Next up is the categorical distribution change section. We saw this a glimpse earlier as well. We'll show you like the 4 columns with high categorical distribution change, as well as a heat map of how those categorical values look like over time. So we can filter on a specific column, for example, payment method, and see if there were any anomalies introduced. We can filter by the top K most problematic values, or filter by a value. Lastly, we provide the profiling tables, so you can explore numerical and categorical metrics across all your columns, across all time windows, so you can really understand the shape of your data. And
Can I edit this dashboard?
yes, you can. The best part is, since we're using Lakeview dashboards, if you have customizations that you want to add, all you have to do is you go up to the draft section. I'm in presenter mode, so we don't see that. But you go into the draft layout, and you can just add any visualization you want. You can add any query you want. You can join on with other tables with the metrics. So that's where it becomes really powerful, because you can really customize what we provide out of the box as well. Cool, so what we saw here is that the dashboard shows you the number of problematic columns, identifies what those columns are, and shows you how they look over time. And this is all out of the box. So Lakehouse Monitoring makes it super simple for you to detect anomalies and diagnose issues. All right, so if we select an inference profile, let me show you what that looks like as well. We get an auto-generated dashboard that looks like this. So we'll have inferences over time, similar to kind of the row count that we saw earlier. But now we also see performance metrics that show you the accuracy, F1 score, precision, recall, and you could get both weighted and macro metrics. And this, you also see all of these metrics plotted over time. So these metrics allow you to track if your model has degraded or needs to be retrained. Similarly, you can also use sections like prediction drift, where you can compare false positives and false negatives produced by the model to track drift in the predictions over time. So has it veered from reliable predictions? You can also see metrics like percent nulls, so data integrity of your predictions. We also have the next few sections are on feature drift. So we looked at predictions, now we're looking at features. We'll see numerical feature drift, where you get to compare features over time. You can also compare it over between 2 different time windows. So I can do between 2 time windows, how much it's drifted, or I can compare it to a baseline to see the quantile plot and how it's drifted. Categorical feature drift here, you can use the heat map to see how it's categorically shifted. And then we'll also provide you all of these data integrity metrics. So you can see things like percent nulls in your features, or percent zeros and percent nans, and how they're plotted over time. The last section here we have is on fairness and bias metrics. So additionally, you can identify if your model exhibits bias against certain groups. So as we can see here, we compute all of these different fairness metrics, and you can slice by a predicted group, for example, like senior citizen. And in general, if you see the fairness ratio hovers around 1, that means that we don't exhibit biases in our predictions, but sometimes you may see that it's biased to say yes to a particular group, and it'll help you identify on the slice of senior citizen. So we can see that our model sometimes produces biased predictions saying yes to senior citizens from this. Lastly, similarly, we also provide all the profiling tables so you can explore the numerical and categorical metrics to understand the shape of your features. So what we showed here is this is all automatically generated for you. You don't need to write these queries yourselves. This is out of the box, and all you had to do was just click a few buttons. But if you want to get this in a more programmatic way, we also have a REST API where you can just call it and create monitors across many tables at once. Cool, let's go hop back into the slides and recap what we just saw. So first, we saw how easy it is to get started with monitoring. With just a few clicks, you were able to get automated profiling out of the box. Next, since Lakehouse Monitoring works on any table in Unity catalog, you can programmatically create monitors with the API and scale this across many tables. And with one unified solution, you can scale this across your data and AI. Lastly, instead of setting arbitrary thresholds that we just kind of use our gut instinct to set, we can use intelligently forecasted metrics that'll guide you to set less noisy expectations, helping you zero in on what really requires your attention. So all in all, Lakehouse Monitoring is simple, scalable, and intelligent, making it easy to get started and scale out across your entire data and AI estate. And as this product builds to more an intelligent future, we plan on making quality even simpler to enforce. So our customers have found our unified approach to monitoring helps democratize and establish trust in the data. So here's an example of how Ecolab found success with Lakehouse Monitoring. Ecolab is a leader in sustainability, and they use data-driven insights in order to optimize water and energy use. So before Lakehouse Monitoring, all of their data science teams were bottlenecked through data engineering. They were trying to understand what the health of the tables were, but they all had to go through this one team. But with Lakehouse Monitoring, they're able to really open up quality access. So let's hear what Giannis, the director of data science, had to say. Lakehouse Monitoring has been a game changer. It helps us solve the issue of data quality directly in the platform. It's like the heartbeat of the system. Our data scientists are excited they can finally understand data quality without having to jump through hoops. So by using Lakehouse Monitoring, you can also build towards that self-serve data platform dream, where all your data is now monitored, reliable, and ready to use. So let me share with you what we're working on next to bring us even closer to that world. So what's coming up next? So first, we showed you what expectations for data quality look like with Lakehouse Monitoring. To be more proactive, expectations allow you to detect and prevent quality issues before they trickle downstream. So many of you may be wondering how this differs from DLT expectations. So with DLT, you've always been able to set quality expectations on materialized views and streaming tables. So we're extending this capability and bringing it to any table in Unity catalog. So what this will look like is we'll unify the syntax. So across DLT expectations, primary keys, foreign keys, and Lakehouse Monitoring aggregate metrics, you get this world where it's a streamlined experience to enforce quality across Databricks. So what this means is you can write primary key constraints like this or aggregate metrics like percent null, and then you can orchestrate your workflows to include an expectation check that will basically enforce these quality expectations directly in your workflows. From there, that's where you can get alerted, you can fail the job, or you can drop a record. And this is currently in private preview. So at the end, we'll show you how to sign up. There'll be a QR code. Along with this, expectations is how we power these health indicators. So you get a health indicator for every table, knowing if it's safe to consume, and a one-click query to help you debug those violating records. And this will be coming soon following the preview. So as we also showed in the demo, you can get AI forecasted metrics. So this is kind of like those beautiful colors that we saw on the dashboard. And this essentially allows you to set thresholds with confidence and reduce noisy alerts. This is also coming soon. Lastly, there's also this aspect of data classification. So since we incrementally process your data, that means we can also classify your data alongside that. So we'll surface all of these PII tags on the column level, such as credit card, date of birth, email. And there's 16 types of built-in classifiers. So these are canonical use cases of PII that we saw, and we'll just detect that out of the box. You'll get a notification saying these are the new types of PII that we detected on your table. And where we're taking this is we're going to integrate with ABAC policies, so attribute-based access control, so that we can support policies on top of these tags and say, hey, mask anything tagged as email, or restrict credit card to only the financial group can see this. And this is currently in private preview. So this is kind of all the previews that we have going on and all the exciting features that we have with Lakehouse Monitoring. I put up the QR codes if you want to sign up for any of the previews that we covered in today's presentation. And also alongside that, we wrapped up the demo in a DB demo so you can easily get started with what we showed today. Thank you for attending our presentation today, and I'll stick around if anyone has questions.